Hello, folks, and welcome. My name is Paul Pindell. I work for F5, and I've been working for F5 for about the last 15 years. I'm in our business development department, and I'm what they call a principal architect, and I work on various integrations and solutions we have with our partners. F5 has generously given me a portion of my time to work with the OPI project, so the Open Programmable Infrastructure project. And in that role, I work with them. I am the outreach working group chair, and that means that I get to do sessions like this, come talk to folks, go to shows, and work with people who are interested in joining OPI and helping us contribute in various ways to making the ecosystem better. We'll talk about that near the end. So again, this is a Open Programmable Infrastructure project. About 2 years ago, became a Linux Foundation sponsored project, and we've been around for about 3 years, but we've been with the Linux Foundation for about 2. June will be 2 years for us. So, Open Programmable Infrastructure, what is it about? Generally, it's about DPUs and IPUs and how we can create an ecosystem around them. But first off, what is a DPU? What is a data processing unit, or an infrastructure processing unit, as Intel calls them? They are on the kind of continuum of NICs. You've got foundational NICs that are simply NICs that transmit traffic to a host. You've got some exotic NICs that do FPGA and offloads and that sort of stuff. You've got smart NICs that are faster. They've got integrated sorts of offloads and that sort of stuff that can be used and taken advantage of. A DPU or an IPU is a little bit different. A DPU and an IPU has on the card itself, generally they come as a card. They can come as chipsets in a server or switch or something like that. But generally for a PCIe card, they are, getting a little feedback, I'll step back. Generally they are cards that have a compute complex on them. So they have compute, memory, and storage on them. And what this does is moves what we call the trust line, the boundary between where the infrastructure would be running in a system. It moves it, offloads that to the PCIe DPU IPU card. And that moves the trust line up above the PCIe stack. Thank you. Here I've got an example card. Like I said, they're a PCIe card. They usually have optics on them. You probably can't see this up here, but optic ports. And they're generally fast network devices. And again, they have underneath this heat shield compute, memory, and storage complex. So it allows you to run services, infrastructure services, on the card itself rather than running it on the host in which it's attached. And they're generally independent of the host. They can be controlled by the host, but generally they're independent of the host, and that allows them to, say, boot up on their own, and you could even determine the, what image you want on the server if you wanted to from one of these cards. But generally they come up and allows you to migrate that infrastructure services off card and provides that isolation barrier so that you can have one group, maybe a security group, an infrastructure team that's managing access to and from that server and to and from the applications that are running on that server, and your application team can worry about just the host server itself. So again, these are PCIe cards. They generally have CPU, memory, and storage on them, and they come from several different vendors. So we've got Marvell, Intel, NVIDIA, AMD, SolidRun, Unifabrics. There's several that are part of the OPI project, different vendors that make DPU and IPU cards. So why should you care about OPI? What are we like to think of this as kind of our flywheel. So we are trying to standardize these cards. So the hyperscalers are the first ones that were able to get their hands on these cards, or they built their very own cards. And they did things in a very non-standard way. Each hyperscaler does fleet management and uses these cards in different ways and has different APIs to integrate with them. The silicon vendors have come about and want to bring these to the enterprise. So that's away, not just away from the hyperscalers, but in addition to using them at hyperscalers, they want the enterprise to be able to use these. And so in order to do that, we need to standardize how these cards are used and how they're addressed and how we can interact with these cards. In previous iterations of Nginx, say a smart NIC, I work for F5, we would have to write our software and our drivers for each and every vendor's card. And in some cases, each and every version of the card as it came out, we would have to write specifically to that card. OPI started, like I said, about 3 years ago when Red Hat, IBM, Intel, and F5 came together to begin this project because we wanted to find a way to standardize how it is ISVs and operating system vendors were able to get their offerings on these cards. So we didn't have to write over and over and over again for each different card that came out. By having standards, it makes it easier to use and deploy these cards and to manage them in fleets, which lowers the cost for the enterprise. The enterprise can now use these because their ability to interact with them is simplified. And that creates a wider adoption, brings the silicon vendors into the organization so that we can continue to standardize and keep this flywheel effect moving forward. So our objective, you can read it here, but essentially I've said we're trying to create an open ecosystem, an API-driven ecosystem that is standard across the industry so that you can interact with and use these cards in a standard fashion. And if you're interested, you can go to our website, go to our GitHub, or join the calendars, that last link there at lists.opiproject.org. So again, moving that trust line up, creating a place where infrastructure can run off of the host, and create a standards-based ecosystem so we can do that. So who are the members? These are the pre-members of the OPI project, and we have 10 of those members right now. And we have, today, we have 4 general members, and tomorrow we're adding a new one, World Tech IT. They start their membership tomorrow on the first. Maybe that's tomorrow, maybe it's the day after, I'm not certain. But the first is when they start their membership program with us. So we've seen strong momentum and progress. You can see who are the biggest contributors. Intel is by far the biggest contributor, or Dell is the biggest contributor, and then Intel is the second largest contributor. And you can see others. You've got Ericsson, Keysight, AMD, F5, NVIDIA, Red Hat, Marvell, and you go down the list, you can see who's contributing. And you can see that the number of pull requests and the velocity of the project is increasing. So how are we structured? We have a board of directors, and then the outreach committee, the outreach working group that I'm the chair of, we report directly to the board of directors. Underneath the board of directors is a technical steering committee. That technical steering committee has 4 working groups right now: provisioning and lifecycle, developer platform, API working group, and the use case working group. And those working groups are directed by the TSC to work on particular problems in the space, and then bring that back to the TSC so we can put them together in a holistic release type fashion. So the different groups and what are their goals each. So provisioning and lifecycle, it's everything from discovery and provisioning and lifecycle management of those cards. How do you determine what card is coming up? How does it get on the network? How do you address it? How do you configure it so that you can put your proper operating system and the proper applications on it? The API and the behavioral model group. So they're creating all of the APIs that are used. And you'll see some of those. I've got a few demos where we'll see those APIs in use. The use case group. This is a group that is going out and talking to customers, deployment partners, one of our members likes to call them. So those deployment partners are service providers, they're managed service providers, they are enterprises that are using these cards in their data centers, in their clouds, and they brought to us their different use cases and how we can tackle them. Some of them are around open virtual switching, IPsec, how do we do a firewall on these cards, how do we use them as a storage device, NVMe storage offloads, and those sorts of operations. So and then the developer platform group, also called the POC developer platform group. This is where we build the software, where we test what we're building, and where we play and build new POCs and new use cases and show how those use cases can come about. So the current activities, provisioning the lifecycle is kind of standardized on OTel. We're using sZTP, secure ZTP, as a initial provisioning mechanism. They're figuring out, they're using Redfish, they're working on Redfish and creating Ansible playbooks using Redfish to help provision, put operating systems and OSs on, and applications on these cards. You can read the rest here. Some of the use cases we'll talk about are IPsec. So we have an IPsec use case. We've standardized on StrongSwan as that IPsec mechanism and the open source APIs that are there. Nginx. So running Nginx as an application on these cards using the open source version there. And how do we do with it a basic firewall and rule-based filtering. And then UPF functions, so for 5G. Those are some of the current activities that are going on right now. So we're at what I call a tipping point. We, as a project, have spent quite a bit of time working on various use cases. And we've got a group that works on this use case and a group that works on this use case. And through that, we've come to understand that there are places where we need to standardize. We've understood where it is we need to standardize. So like the first one is, how do we know that the card that we're interacting with is the proper card? How do we get a certificate that the OPI APIs can read and understand? So we're working with the silicon vendors to figure out how to standardize that. And that's just the first of many. We're shifting our focus as OPI, not shifting our focus, we're shifting what we're going to deliver first in the next couple of months. What we're working on is, instead of working on individual use cases that go from top to bottom, like IPsec or the OTel for monitoring or using sZTP for provisioning, we're trying to find and create the building blocks that enable all of those use cases and work on the problems that are seen across the industry and how we can standardize those building blocks. We'll be putting those building blocks together, and it'll help us bring all of those use cases together into a cohesive whole. Part of that tipping point, and part of the reason that we're here, is that we recently, in the last 3 months, spun up what we call the OPI lab. So we've got a lab. It's running in a Hurricane Electric facility that is in Fremont. And that lab has various server hosts in it that are hosting DPUs, and it's got all of the major DPUs running on those hosts. And it's a place where we have a full CI/CD pipeline that allows us to build and run each of these use cases and test them. And I'll show you some of that here in a little bit. But it's a place where we've seen some of the problems, some of the gaps where we need to go in and fill those gaps. So anyone who's interested in joining us, come fill gaps, find places where they can write code and come up with great ideas on how to fill those gaps. We're open to that. You can see that this is an early picture here in the middle of equipment going into the lab. One of the things that we've been working with quite a bit is, you can see on this far upper right picture, this is a particular DPU. I think it's a Marvell card. I'm not positive. I don't know which one it is. Mircha would know. Yeah, I think it's a Marvell card. And one of the difficulties is trying to figure out and standardize and understand, how do you just connect the auxiliary power to these? They use a GPU power cable generally, but depending on the server model you're putting it into and the card that you're using, they have different pin outs and different ways to connect. So working on that, that's why that picture's here. And then you can see spaghetti cable in the back of a rack there as well. So we've got a couple of demos that I want to show. In the past, I've shown sZTP provisioning demos, so I'm not going to do that one. That's already available on our YouTube channel. You can go check that out. And during that, I showed how to use sZTP. We have additional Redfish. We're building the Redfish API calls and Ansible playbooks to be able to use those calls to provision these cards. And I'll show some of that. OTel is another standard that we've embraced as a project. So we're using the Open Telemetry project to get telemetry off of these cards. How much CPU are they using? How much memory do they have left? How hot are these cards running? How hot are the servers they're in running? That sort of thing. Show you some of that. I've shown Nginx on a DPU in a previous session at OCP last year, I believe, was when I showed that. That was running on, I showed that running on a Marvell card. I think I've got showing it running on an Intel IPU this time around, and we'll show that really short demo. We've also got demos around EVPN storage, and we'll show some an IPsec storage, IPsec Strong Swan VPN use case on a NVIDIA Bluefield card. So provisioning with Ansible. We've got in our GitHub, there's the playbooks that we're using and developing and how we're utilizing them and how we can go about doing that. We're looking for folks with Ansible skills to come and help us build those playbooks out and make them, flesh them out even more. So that's our the first POC that we've got going. I'm not going to show a demo of using Ansible. I think many of you have seen that. You'll see a playbook run by. That's pretty normal. So monitoring and telemetry. So we've got the ability to put an agent on each of these, on most of these cards, and on most of the servers, on the switching infrastructure and different things within our lab, and we're monitoring that. I'm going to go show you, if I can, if demo folks work well with me. Here we go. Here's just an example of a dashboard showing the temperature of the various devices that we've got running in the lab, the memory and CPU of those devices, showing that we are pulling the telemetry from these cards and able to, using Prometheus and Grafana, demonstrate those on our web page. So you can see that. Go back here. And again, we've got in our OPI project, OPI POC repository, we have got a GitHub that shows how we're provisioning OTel and how to run those demos, how to run the server-side stuff. And it's tied into our CI/CD pipeline. So as we release and add new code, it's tested and run against the DPUs in the lab. IPsec Strong Swan. So Mircea, who's here in the room, built a couple of demos. He did that on each of the cards. He showed them running on an Intel IPU, on an NVIDIA card, and on a Marvell card. He got those running using the OPI APIs and how that was up and running. So I'm going to run that demo if I can. That is not the one I want. I want that tab. So again, he ran it on an NVIDIA Bluefield on the Dayton Peak card and the Marvell CN106. And so it's terminating an IPsec tunnel on the card itself and passing that traffic on to the host. So the processing of the IPsec tunnel is being done by the DPU rather than, again, it's another infrastructure task that's being run on the DPU, rather IPU in this case. No, this is a DPU, a Bluefield, rather than running on the actual host itself. So that allows the host to have more cycles to run its workload application. And you'll see here that we're using Keysight's SciPerf to stress these cards and to run and make sure that things are working on them. You can see he ran a script that actually is one of those we use in our CI/CD pipeline that sets up the IPsec tunnels using the OPI APIs, and then the SciPerf performance testing from Keysight is going through, and you can see a dashboard of those sessions coming up and what's happening there. So you can see on the dashboard that they're coming up, and more tunnels are coming up, and more connections are going through those tunnels, and how many connections and what the throughput is through that tunnel to the host. And again, using test scripts that are in our GitHub repositories, you can go find those there. And we'll stop that one, go back to the slides. Next one is Nginx on a DPU IPU. So in this case, we're running you can see here we've got a DPU IPU. In this case, I believe I'm running it on an IPU. And we've got running on the DPU, we've got the Nginx proxy running there. And we're generating traffic, sending it through one of the interfaces on the DPU, and it's coming out the other interface on a DPU and being load balanced to a group of Nginx web servers that are outside of the host. We could also send this traffic to a web server that's running on the host itself across that PCIe bus, but I don't believe that's what we're showing in this demo. And I wish this were a little clearer. Does it get any clearer? It does. Okay, so you can see that we've started Nginx Plus. We know that it's running on the card itself. This is an Intel IPU. This is the config that we're using. We're going to be sending traffic to that address, and at this point, we're just going to be returning a string to make sure that we are connecting properly. You can see here we've got just a curl command. We're curling to that and we're dumping it so we can log it. We've commented everything else out except that curl script for right now. Running that test, and essentially what it's doing, you can see here that from the outside into the DPU, Nginx running on the IPU, the ACC, the Accelerated Compute Complex, we're able to use Nginx as a web server and to proxy traffic to another web server that's running outside on a external host. So again, moving that infrastructure component from the host, running it on the IPU or DPU in such a way as to allow that host to have more cycles to do its work. I've got one more demo here, and I'm not going to show the full demo because it's 20 minutes long. If you want to see it, come to the booth. We've got a booth over in the corner of the showcase space. You can come talk to us. There'll be several of us manning that booth, and you can take a look at the demos that we have running. Essentially, this is a Kubernetes network offload. How do we offload the processing of the Calico CNI? It's running on the Calico CNI is running on the host itself, and there is an infrastructure agent that runs on the host that communicates with in this case, this is a Mount Evans or a Dayton Peak IPU, and it communicates with that IPU in such a way that it changes the rule sets on that IPU. So whenever the CNI requests or makes a change on the networking connections that are needed. And I'll just show a little bit of that video, and I have 4 minutes left. So again, it's how do we offload, and there's a section in here where we talk about the two different two different use cases that we've got. One is offloading that functionality for pod-to-pod connectivity. How do we use the DPU to restrict and create rules and policies for how does one pod in a Kubernetes cluster communicate with another pod in a Kubernetes cluster. And you can see the more detailed stuff at the booth if you'd like. The next one is a server load balancing demo, and I'll see if I can find the picture. Here we go, server load balancing. Again, it's how do we load balance to across a set of pods that are running the same containers, the same use cases, they're the same replica set. How do we use the IPU to load balance to those various pods so that we have a scale out group there. All right, back to the presentation. We've got storage demos that we can show you at the booth as well. And here's the slide that I hope everybody takes notice of. This is how you can join us and participate in what we're doing at the OPI project. So we have a mailing list. You can sign up for the mailing list using that link. We have Slack channels. That's our normal way of communicating with one another. Obviously, we're doing everything in GitHub, and you can come to GitHub and look at the code that we've written, look at the documentation we have, and understand what the project's about, and join in and contribute. And if your company or yourself, you want to join and become a member of OPI and pony up some money to help us move the cause along and maybe get a seat on the board, some other sort of things like that in becoming a member, you can click on the last one to become an OPI member. And last, here's the great picture of the map. We are up here in the upper corner at booth B6. Come by and see us. We'll show you those demos. We'll talk to you about what's your ability to come and help OPI out as a project and what you'd like to do in that space. Thank you so much. And that's the presentation. I think I've got like 2 minutes. Is there a question? And if not, I'll go have more coffee. Excellent. Thank you all for your attention.